Hello friends, welcome to my channel. Most of the people use this shift register IC, which is basically a 74HC595, to display the countdown or the numbers on a 7 segment display. But do you know that there is a hidden pin on this shift register IC, which is called the OE pin, which can actually control the brightness level of all the 7 segments on the display. So in this video I will show you that how you can control the brightness level of all the segments on this display with the help of Arduino, right? So let's start building this project. And you can see in this display the brightness level is gradually increasing. Now to test which one of the segment is common anode or common cathode, we need a multimeter. So this is a multimeter and we need to set the knob of this multimeter on the diode testing mode. So this symbol, you can see this is a diode symbol. So we can use this mode of the multimeter to test which one of them is common cathode or common anode. So we need two jumper wires for this purpose. One I will connect to the common pin. So this middle pin of the segment displays the common pin. So this will act as a common pin. And other jumper wire I will connect to any of the segment LED. Let us connect it in the upper one. Now I will connect both of the probes, that means black and red, to each of the jumper wires one by one. So first of all I will connect the black probe to the middle pin, that means the common pin, and red probe to one of the LEDs. You can see the LEDs are not on, right? Now let us try to switch the position. That means now I will connect the red probe to the common pin and black probe to one of the LEDs. So you can see the LED is on. So that means it is a common anode because I connected the red probe on the common pin and LED is on. So this is a common anode. Now let us try to detect whether this is a common cathode or common anode. So I will connect this jumper wire on the middle pin, that means the common pin, and other jumper wire on the one of the LEDs. And same procedure I will repeat for this segment also. So I will connect first the red probe on the middle pin and black probe on the one of the LEDs. You can see the LED is not on. Now let us try to switch the positions of the probe. Connect the black probe on the middle pin and red probe on one of the LEDs. You can see the LED is on. So that means this is a common cathode because we connect the black probe on the middle pin, that means a common pin. So in this way you can test the whether 7 segment displays common cathode or common anode. Now let us discuss about the pinout of the shift register IC which we will use in this project. So we are going to use 74HC595 IC, and this is a C4 register, that means serial in parallel out. And the reason I will discuss after a while after discussing this point. So now let us discuss all the pinouts one by one. First one is a DS, that means data pin. So this is where the data bit, that means ones and zeros, enter the shift register, right? And Arduino sends a bit here, one bit at a time. So what happens? Whatever the data you are entering from the Arduino, that enters from this data pin, and from these pins Q0 to Q7 you can get the output, right? From all the pins Q0 to Q7. So that is why it is serial in parallel out, because DS is the only pin which from where you can input the data, and Q0 to Q7 pins are the pins from where you can get the output. So that is why serial in and parallel out. You can get all the 8 parallel output at the same time. Now let us move on to the SHCP pin, which is also called the shift register clock. That means SRCLK, both are same. So this pin is related with the timing of the entrance of the bits from this data pin, right? So every rising edge, that means when the signal goes from low to high of this clock pin, it shifts the bits inside the register one step forward through this data pin, right? So this SHCP pin is related with the entry of the bits from this data pin. Now STCP pin, which is also called storage register clock. So sometimes you will see RCLK and sometimes you will see STCP, both are same. So this pin transfer the data from the shift register to the output pins, right? So this pin is related with the, that means STCP is related with the output of the bits, and SHCP is related with the entrance of the bits. And without using this pin, the outputs won't update immediately. That means they only change when you use STCP pin. So we need to use this pin if you want to get the output from the pins Q0 to Q7, right? Now let us move on to the very important pin, the OE pin, that means output enable, and that is a very secret pin, you can say, because most of the people ignore this pin, and they generally connect this pin to the ground. But you can actually control the brightness level of all the 7 segments LEDs using this OE pin, right? So this is the OE pin, pin number 13.
So this is active low, and when this pin is low, that means when you connect this to ground, the outputs are active. That means LEDs will glow. Otherwise, if the OE is high, that means the output will disconnect and the LEDs don't glow. And we are normally connect this OE pin to the ground, and we can also connect this OE pin to the PWM supported pin on the Arduino for brightness control. That is why it is a kind of secret pin, right? Because most of the people generally ignore this pin and connect to the ground. But actually, we can control the brightness of all the 7-segment LEDs using this pin. Now here is the important pin, MR pin, master reset, pin number 10. So when MR is low, that means all the shift register bit will be cleared. That means Q0 to Q7 we will get zero output. And we normally connect this pin to the VCC to keep it inactive. And this is the last pin, Q7 dash or Q7S. We use this pin when we use multiple chaining for 74HC595 ICs. Okay, and we can connect this pin to the DS, that means data pin of the next shift register IC to get or extend the outputs beyond the 8 bits. So this is about all the pinouts of the shift register IC. So this is the circuit diagram for our project. I am using currently common cathode. I will also show you the common anode also. But first of all, let us discuss about common cathode. So you can see total of 10 pins here, right? Two middle pins are the common pins, and rest of the 8 pins are the digital pins for the LEDs. And this is the pin called DP, that means decimal point. Suppose if you want to use more than one 7-segment display, then to display the decimal point between the numbers, this pin will be used. So I'm not using this pin right now. I'm using only the 7 pins, right? And for the IC, this is a power pin, that means VCC. This is a ground pin, and this is the inverted output, that means which corresponds to this pin, Q7S, right? And this is a shift register clear, shift register clock, output register, output enable, which is the OE, and this is the input pin, right? And these 8 pins are the output pins from terminal 1, terminal 2, 3, 4, 5, 6, 7, and 8, right? So if you want to connect the DP pin, you can connect it to the output 8, right? So this is a complete circuit diagram for the common cathode. Now let us change it to the common anode, right? Now only one thing will change. You need to just extend this wire from negative terminal to positive terminal, right? Because it is common anode, so the common pin will be connected to the positive rail of the breadboard, right? So this is the complete circuit for the common anode. So circuit diagram for the common cathode and common anode are very simple. Just you need to change this wire for the common pin, right? And one thing you need to keep in mind is that you need to connect the pins of the 7-segment display in the order like this. Q0 will be connected to A, Q1 will be connected to B, Q3 to C, and likewise Q7 to G, right? And you can see the pinout of the 7-segment display here. This is connected to Q0, B will be connected to Q1, and likewise you can connect all the pins, right? So this order is very important for the proper display of the numbers on the 7-segment display.
So this is the demonstration of common cathode 7-segment display, and you can see the counter on it, right? And the same kind of demonstration you will see on the common anode 7-segment display. So this is the demonstration for common anode 7-segment display. In this you can see this jumper wire is connected to common pin of the 7-segment display, and other end connected to the positive rail of the breadboard, and positive rail of the breadboard is connected to 5 volt of the Arduino. And in the previous demonstration you can see this jumper wire was connected in the negative rail of the breadboard because that was a common cathode, but now this is a common anode. So that is the difference between the common cathode and common anode.
So this is the code for our project, and this code will work for common cathode as well as for common anode. You need to do just a minor changes for both the cases. And I'm defining 3 pins, data pin, SHCP pin, and STCP pin of the IC. And common cathode I will use 1 for on and 0 will be off. And for common anode it will get reversed, that is 0 for on and 1 for off. And I'm defining all the patterns 0 to 9 in this digit patterns. So you can see this order is in the format this. First bit is the decimal point, second one is a G, third one is F, and all the way up to A. So you can notice that in each of the cases, the decimal point bit is 0. You can see all the bits are 0 in each case. So this pattern will be used for common cathode and this will be used for common anode. And please note that in this code I am not using the OE pin, which is used for the brightness control. I will also show you that code in which I will control the brightness of each of the 7 segment LEDs. Now let us move on to this function show digit. So in this I am defining 3 lines. First one is the digital light. I am using the low signal on the latch pin. So this line tells the IC, that means 74HC595, to stay in low position while the Arduino is sending the bits into it, right? And this shift out function is the Arduino's built-in function, which send the 8 bits into the IC serially, one by one. And MSB first means most significant bit will be sending first. So most significant bit means the leftmost digit, this one. So this will be sending first into the IC by the Arduino. And in this part of the code, we are defining which pattern we want to print. That means 0, 1, 2, or 3, 4, 5, up to like 9. Right? So this is a complete code for the display of the pattern on the 7 segment display. Now let us move on to the code in which I will use the OE pin for the brightness control. So this is the code for the brightness control of the LEDs. You can see the OE pin is defined on the digital pins of the Arduino Uno, and it must be PWM supported. Otherwise it won't work. So everything is same as the before. The only change is done in the word loop function. This extra for loop is there for the brightness control. So we are increasing the brightness from 0 to 255, and in each step the brightness is increased by plus 20. And we are uh, writing the brightness level on the OE pin using analog write. So you must do 255 minus brightness and not brightness minus 255, because the OE pin is active low by default, right? So brightness minus 255 would be wrong. So everything is same as the previous code, right? So this is the complete code for the brightness control. So I hope this code is clear to you, and if you found this project helpful, like and subscribe to my channel and comment your doubts regarding this project, and we will meet in another video with a new project. Till then, goodbye.